Okay, class, so now we're on to our Skilsaw lesson. I've given you some cut lists that we're going to go out to the shop and cut. I've also given you a diagram of the parts of the saw, but let's go over those real quickly. So up front here we have the bevel lever, so that we can loosen this and set our table or our foot of the saw to a certain angle for bevel cut across our material. This is my lower guard and its lever. This I sometimes might need to raise out of the way to make a safe cut. This is my depth lever and then my adjuster to make sure I'm not cutting too deep through my material. This is my top handle, my rear handle with the trigger. Here's they used to call this a rafter hook, but really it's a hook to grab on a piece of the 2x4 or on a hanger on my sawhorses to keep it out of the dirt, out of the water, or from getting dropped and kicked. This, of course, is my cord. So there are two main hazards with a Skilsaw. There's a kickback, which is where the blade binds up and this little burly motor shoots the whole saw back at you, which can be very dangerous. This guard is here to protect us, and this one works pretty good, but it still can't be as fast as a kickback. So sometimes, somebody's body gets in the way, but we'll talk more about that in a moment. Our other issue is electricity. So when I select a saw, when I go to the shop and I'm picking a saw to use out in the job, I'm going to take a quick minute, I'm going to run my hands, and I'm going to visually check to see if there are any cuts in this sheathing or in the actual copper wires that might expose me to the electricity. Make sure that all my prongs are here on my end. A lot of times this ground prong goes missing. If we have any of that, we're going to put a tag on here to have it sent out to be repaired, which needs to be done by a qualified person, which in this case would be an electrician if we needed that fixed. One way to prevent kickback is to have a good sharp blade. So I also, as I'm checking to make sure all my levers work, I might take a second with the saw unplugged and spin the blade, and I'm feeling the tips of the teeth here, and I'm also looking for something like this guy right here. I'm going to pull this. This is my blade wrench, and also adjust some other things on the saw. But if you see right here, that's one of the carbide teeth is missing from the saw. So this guy's dull. Maybe not horribly dull, but dull enough, I'm going to change it. So first thing I need to do is get the blade off. So back here, this little button right there, that goes into a notch in the spindle and lets me loosen that blade. So I'm going to push that button in, a little hard backwards, but we can do it. And then I'm going to put my wrench on here, and I'm going to go left and right until I can feel it's in the notch. Now this bolt is left-handed thread, so instead of being lefty-loosey, it's righty-loosey. So I get my wrench on there, do a nice little pull, and take my bolt off. At this point, I can let go of that button. I'm going to loosen this bolt all the way. Sit over here with the wrench, pop the blade out, and as you can see, this guy's pretty burnt up. Here at the apprenticeship school, sometimes we have some issues with people being new to a Skilsaw. Most of the teeth don't look too bad, but that one's missing, so I'm going to get us a new one. Here's a nice new blade in the package. But you'll notice, let me get this rubber coating off the teeth. If you notice, they don't have the same hole. This has a diamond and this one has a circle. Well, they make these blades go not only with these worm drive saws, but with the direct drive, where the blade goes on to the right side of the motor. Sometimes they call that a sidewinder. So this circular arbor hole is for the sidewinders, but for us, we want that diamond. So here's another use for our wrench. Go right in that arbor hole, give it a couple little pulls in a couple different directions, and that little diamond pops out. And put it with the other blade to throw away. Another thing to know about the teeth is, or about the blade, is the label always goes down into the saw, which means the teeth will face, the exposed teeth will face the front of the saw. So I'm going to remove that guard, rotate my blade until it's in the right spot. It's in the right spot on the spindle. Put my washer on, and I usually forget which way to turn it because it's lefty-tighty now, and I finally got it. Here we go. So I spin that on. Here's a safety feature that's designed into the Skilsaw. I've got this finger tight, and I don't want to crank this as hard as I can get it. They've designed this blade to be able to spin, to slip a little bit in case it binds up. Now it doesn't protect you 100% from a kickback, but it will lessen the likelihood of a full kickback. So I've got that finger tight. Now I'm going to reach back and push the button into the notch. I'm going to go maybe an 1/8 to 1/4 until it feels snug but not wrenched on. And that should be good to go and ready to cut. So I'm going to put the wrench back in there. So another way to prevent kickback is to not cut between your sawhorses or your whatever supporting the material. If I try to cut this 2x6 here, right across there in the middle, as I cut out, so I get about 2/3 or so across the board, that curve I've cut is going to allow this piece of 2x6 to pinch in on itself, and it's going to grab my blade, and the motor is going to force it back. So to prevent that, I never cut in between my sawhorses. I shouldn't say never. I never cut all the way through something between my sawhorses. If I need to make a notch, I might do it in here, but if I'm going to cut all the way across, I like to do out here over on the side. And however my setup is, most of what I do, this can fall and hit the ground. It's not going to be a big problem. If we're doing finish work and the material might matter, I may not be using a Skilsaw, and if I am, I'm going to have it set up maybe like I have here, where I've got a nice table with some material raising my piece I'm cutting up off the table, so that piece can drop, but it's not dropping very far. Another way I like to prevent the blade from binding up is, if I'm cutting this 2x6, I don't want to cut it flat like this, because it's going to spin. And then blade gets bound up and it might try to kick back. So what I like to do is I raise it up, I don't know, 15, 20 degrees, and then I can cut straight down, and not only is it pushing into the support, which keeps it from spinning, but now the weight of the saw is helping me make the cut. So that's a straight cut. Another type of straight cut we'll do a lot is called a rip cut, where I cut down the length of the material instead of across. Very simple to do, but what I might want to do is I might want to nail this board down. That way I'm not trying to hold on to it either as I cut this way, or if I might be behind this blade, and if I get a little wobbly, it might kick back, and that could be very dangerous. So I might take a couple of flat-headed nails, like a 16 sinker, and nail this board down. And then I can make my mark and I can make my rip using both hands on my saw, and then I'll be safe. A couple more cuts we make across the material are a miter cut, which is where I cut at an angle across the wide face of my material. And again, I might clamp or nail the board down so that I can use both hands, because as I push here to an extreme angle, like above 45 degrees, my guard might not push itself out of the way as effectively. So if I've anchored this down, I can then raise my guard, and when I raise my guard, I like to grab it with my ring finger and my pinky before I've started the saw. And then I can get my hand up on top and hold this top handle, and that keeps my fingers from being able to slip in any way into the blade. I know there are some people who will push the guard with just their fingers out here, and I've seen this happen where someone slipped and then cut part of their thumb off. So we want to keep our hand in a position where it can't slip into the blade. So that's for a miter cut. Another cut I will make across is a bevel cut. So I take my bevel lever and I loosen it up. And in this nice newer saw, it's a little stiff, but we push the guard to our angle. We select that angle with this little pointer and these degree marks that are on the guard there, or on the table, excuse me. And then I lock my lever down, and now I can make my bevel cut. So a bevel cut is straight across the material, but with my saw set at an angle. And I can make it just like a square cut. I can pick it up and push down, and that way I won't spin like if I do it just flat on the support. Last crosscut we make is called a compound miter. So a compound miter is a combination of a miter and a bevel. So in this case, maybe I have a 45 across the face of my material. My saw is set at 35, as I did just a minute ago. So again, this is one where it's nice to have the piece held down by clamps, nails, or as we're going to do when we go to the shop, having your partner hold it for you. And then I can again raise my guard, push across the material, and usually when I'm making a cut, I try to watch the blade here. But with the compound miter at such a steep angle, I lean up and I look down. That way I can see where my line is and I can make a nice clean cut. It does put me in a little bit more of a dangerous position, but as long as I don't try to get back on, if I get off my line, as long as I don't try to fight it back to the line, I should be safe and it should not kick back. One more cut we make that we might make here in this 2x4 potentially, but make it a lot of times in plywood. It's called the plunge cut. So plunge cut is where I'm in the middle of my material with my saw, and I need to make, say in this case on this piece of 2x6, I make a notch right here. So let's say I'm making a notch. I'm going to make a couple of cuts coming in to my lines I've marked, one on both sides, and then I'm going to have a line across here, and I'm going to take my saw, and I'm going to get it lined up, and I'm going to raise my guard out of the way, and I'm going to, with the toe of the saw of the table down, this is important, with the toe down so that I'm pushing in the material, then I plunge my saw down. I don't want to go this way. If I go from the back of the table and lean forward, the way that blade is spinning, it's going to run back out of the material, and then I can potentially get injured from the blade kicking back out of the cut. And just like rolling it in, which is wrong, if I make my cut, I plunge in, and I say I missed my line that I marked back here, I don't want to go back. Same thing in plywood or anything where I'm making a straight cut, even a rip cut. If I go back, again, I can potentially rotate the saw, and then it's going to bind up and it's going to kick back. And if I'm going, even if I'm off to the side in a safe location here, if I turn it too much, it might run up out of the material at me. So to prevent that, I never go backwards. I only go forwards. Now, if I happen to miss my line back here, I'm just going to let my saw come to a complete stop. After I've reached my front mark, I'm going to raise it out, and then I'm going to come around and I'm going to raise my guard and do a separate plunge cut just to finish that side off. That way I stay safe and I still get my notch cut out of this 2x6. So now that we've talked about the safe use of this saw, we're going to go out to the shop, and I've given you that cut list, and I want you to pair up. Probably we're sitting in 2 people at a table. I think we'll just make that your pair. We'll go out to the shop. You'll each grab a pair of saw. For each group, we'll grab a pair of sawhorses and one saw and an extension cord, and we'll gather up some material to cut. And like I said, as we go, if you have any questions, come and ask me, but I'll also do a demonstration when we get out there of how to safely make all of these cuts. And so let's head to the shop.